here we are, end of the first day of Breakpoint 2022. I hope you guys enjoyed this. So I'm Austin Federa. We're going to talk a little bit about what's been going on the network over the last year, some of the things that we're looking forward to. But first, I wanted to call out a few things from today. The first being Kevin Bowers and Fire Dancer. I think that was one of the really impressive presentations to see. There's a 45-minute technical demo, which is actually working code in a DevNet environment, to be very clear, not on mainnet. Don't want folks to misconstrue some of this. But this is where the performance of the network will be heading as a lot of these improvements start shipping to the network. So this is an early look at stuff that you can see rolling out over the next year. Check out that 45-minute technical workshop and demo. I think that's going to be really interesting. We heard a bunch of great updates on SMS and the Solana mobile stack today as well. And of course, Google Cloud making some pretty serious inroads into Web3 and Web3 with Solana. So looking back, right, this is an image on the right that very few people remember, or that right if you're over there. This is actually from 2019. I don't remember this image. I was not involved in Solana at the time. This is from Osaka, Japan. This was the first Solana, I guess, Breakpoint before Breakpoint conference. You can see last year, and you can see this over this morning. So really what we're seeing is incredible growth through the ecosystem and the community. It's come so far in just a short period of time. So we are, of course, coming to you today in a bear market. And Solana is we've been through this before. Solana launched in March of 2020 on mainnet beta, right after the world went into lockdown and the economic crash associated with that. And so a lot of you in the audience were actually here and building for that. A lot of you are new to the network, and this is sort of the first experience with this. For those who sort of sat through and built in the previous bear, thank you. For those of you continuing to build today, there's never been a better time to get building on the network. This is where the noise goes away, the signal gets amplified. This is a builder's market. And these are just a small number of the companies that were all founded in, we call them recessions outside of crypto, but in the bear market. And really the message here is that some of the best companies in the world have been founded at times when other people were afraid to found companies. And so keep that spirit with you as you interrogate your products you're building, the use cases, and the future of things on the network. So let's talk a little bit about the last few years and where things stand today. Hacker houses. Hacker houses started as an idea at Breakpoint last year, and there's been over 24 of them this last year. So 64,000 people have participated in either Solana hackathons or Solana hacker houses since the network went live. This is an incredible number of folks. This is the transition from Web 2 to Web 3 that we're talking about. 64,000 people is both a very large number and a very small number at the same time. But it's the beginning of a trend that you only see accelerating as folks move from Web 2 to Web 3. And you see web companies like Google embrace Web 3 as a future for them, and companies like Instagram, who you heard from earlier today as well. So hacker houses. I'm excited to announce the 2023 lineup for hacker houses. This is an incredible list of places that all have either strong Solana communities right now and active support, or they're areas that we've seen incredible projects submitted to hackathons from around the world. So this is a list of cities. The registrations will be up in the coming days. You can find more at solana.com/events. But these are really like an incredible component of taking an online community, bringing it in person for a period of time, just like Breakpoint, catalyzing around an idea, and then going off and building what your ideas are. So let's talk a little bit about decentralization and validators. Validators are the heart of everything on the Solana network and everything on a blockchain. So over the course of the last year, Solana has quietly become the world's most decentralized proof-of-stake network. It has the highest Nakamoto coefficient. It has over 3,600 full nodes running, over 2,000 validators. These are numbers that are not matched by other proof-of-stake chains when you look at the overall picture of decentralization that comes through. There's 230 different unique data centers that folks are running validators out of. These are block-producing, consensus-participating validators in over 33 different countries. This is an incredible accomplishment for a network that is only 2.5 years old. Setting aside the fact there's a whole separate validator client implementation that's being worked on by the folks at Jump from FireDancer. So activity on the network. Let's take a look at what that looks like today. Now, there's two metrics that are very important to look at here. The first is accounts and active accounts, and the second are active fee payers. These are slightly different things on the network, but they represent different types of user activity. Now, these numbers are clearly down from their peak, but what you're showing here is real staying power across the network. That people who start building on the network and users who start using the network, it's a sticky place. They're sticking around. They're experiencing all that DeFi and NFTs and Dows and gaming and all this other amazing stuff we'll talk about has to offer. So digging a little deeper into this is developer activity on Solana. Now, there's thousands of developers building on Solana. On the left, you see active GitHub repos. And this is probably the best proxy we have for developers actually building on the network. Now, this is, of course, only public repos. If your project is in private mode and hasn't launched yet, or you're building something closed source, we can't really track what this looks like. But these are projects in active development. Additionally, there are over 1,000 programs on the network with transactions going through them every day. This is also pretty impressive when you realize that a whole point of Solana is program reusability. So it's not like every time someone mints an NFT, they have to deploy an entirely new NFT contract, which would show up in a program count. So these are really exciting numbers. I'd love to see the activity, especially the GitHub repos increasing. I think some of this is folks just finally getting on the open source bandwagon, which we're really excited to see, but it also represents real growth as well as the network. So where is Web3 headed? Right? This is a pretty famous chart of the internet adoption in the United States. Now, the United States is just one small market, right, in the world, but this is kind of where a lot of this adoption started for consumer technology. So you go back to 1995, and what you're seeing is that about 12% of the US population had some access to an internet connection and was online. Today in crypto in the United States, there's about 12% of the population that owns a digital asset, blockchain tokens, crypto. Now, ownership, I think, is a pretty poor metric for participation. That could be folks who go through centralized exchanges. That could be folks that never have held their own keys. They don't have a ledger. They're not doing self-custody. So we're actually probably even more early than that. But this is that transition that we're just at the very beginning of. All the activity we're talking about here, all these active users, all of the updates we'll go through, we're still at the incredible beginning of this journey in this cycle. And that's really a thing to keep in mind here, is that where we are today is, it can feel like crypto has come such a long way in just a few years. We're still in like 1995. There's so much left to do, and that's why you're all here today and why we're all here today. So before we talk about some of these areas of focus on the network, it's important to remember that new paradigms are needed when you switch technology paradigms, right? The move from Web 1 to Web 2, we had to reinvent a whole bunch of vocabulary to be able to describe what these things actually are. So we're going to go through some categories like NFTs and DeFi and DAOs and all these sorts of things, but all of these are approximations of models to fit certain kinds of ideas, right? Gaming on blockchain, it's not gaming on Web 2 just moved to blockchain. It's a combination of NFTs. It's a combination of DAOs, maybe. It's a combination of tokens and DeFi, right? These are intersectional concepts that all roll together, and we'll come up with new names as we go. I don't think NFTs are going to be the sticky name for the future. I don't think DAOs are going to be the sticky name for the future. And because this all exists in a composable environment, these things all intermingle with each other. And that's the whole point. That being said, let's talk about games. So 2022 has been a landmark year for games building on Solana. So games on Solana have this thing where they're fast, they're cheap, they're composable, and we're starting to see a beginning of a shift from centralized games that run on pretty much all Azure to systems that are actually both built on blockchains and interacting with blockchains. This is a shift from this sort of model where you either play to earn to something where you're playing to own. We are taking games that are actually fun for the sake of the game. They're not just DeFi wrapped in sort of a nice UI. And this is a really big shift both for the gaming industry and for opportunity. Games have historically led the adoption curve in areas before. You saw mobile games taking off far before you saw other types of mobile applications taking off. And so this is kind of a leading indicator of where things stand. So Solana Foundation Games Day, how many of you went to Games Day? Great. Awesome. Glad to see that. So Games Day happened just yesterday, which is hard to believe. But this showcases fun, player-driven experiences built on Solana. And so what we saw there, if you were one of the 1,100 people who were able to come to Games Day, was over 15 games that are live and playable on the network now today. There's about that number's expected to rise to about 37 by the end of Q1. And these are, again, these are not just DeFi with a UI on top of them. These are game-first experiences that are testing out new models of what it means when your player identity and your player reputation can move from one game to another or one game network to another. You're not locked into this idea of like, oh, I'm only an Xbox player, or I'm only a PlayStation player. You can bring that portable identity with you. So this is one of those things that games at the beginning of 2022 were just sort of an idea on Solana. There were a lot of people spending a lot of good time building them, but there wasn't anything playable. And so I encourage you all to check out some of the footage from Games Day as well. I think over 1.5 million people turned in remotely to actually watch some of the play demos that took place. So really excited to see that. Moving on to DAOs. So since last year, the DAO tooling on Solana has matured to the point that many projects are actively managing treasuries and their community governance on-chain. So DAOs are a term that we use to describe a piece of technology. DAOs are actually a cultural transformation in the way that communities engage in the process of self-governance, right? DAOs have the ability to rewrite what the idea of the corporation is, and to change the relationship between someone who's a member of a community, a shareholder, someone who's a citizen. All of these things get blurred together in the concept of a DAO. And so we're at the very beginning of this sort of DAO explosion. And so you can see some pretty impressive numbers here. I would say that over 7,000 DAO proposals, over 31,000 people actually participating in on-chain governance. This is the idea of rebuilding the idea of digital community in a way that's owned by the participants. So DAOs are not one size fits all, right? It's not like you have to DAO everything or you DAO nothing. There's parts of different online communities, be it an NFT community that's now voting on proposals on how to use their royalty treasury, if they still have one, via DAOs. Or it's full projects like Mango who have taken almost everything and brought that to be the decision of the DAO. So there's a whole spectrum here, and it's something that folks can really build and choose how they want to use it. There's investment products being built using DAOs now. There's a lot happening in this space, and I think it's really interesting to see where this will head in the future. Moving on to payments. So Solana Pay launched in January of this year. It's hard to believe it was just in January, as truly decentralized payment rails. So this enables a new type of commerce experience that is open to small businesses doing in-person transactions, online and web merchants, and giant multinational global brands such as ASICs. This is a transformation of a model that moves from paying for something as a one-time transaction to building potentially things like loyalty on-chain, to build relationships that involve not just a physical item, but a digital item. We're not just taking a book and selling an ebook here, right? It is a transformation of what payment rails enable. And it's important to note that the point of payments is not just to reduce the cost of transaction to near zero, and it's not just to allow instant global settlement of any dollar amount anywhere in the world. It is to build up people's functionality on chain. that transition from saying, you know, I use a debit card, to I use PayPal and eBay, to I'm a fintech user on Robinhood. That isn't accidental. That's because a whole series of technological innovations led to that. And payments on chain and getting that tooling really strong, that brings more users into DeFi. When you already are paying people through something like USDC on Solana, it makes more sense to use DeFi products built on these kinds of networks. You no longer have to go through the process of how do I get funds out of my bank account and onto a blockchain to experiment with something new. If they're already there, if anything, that process is reversed. How do I get funds from USDC out of the blockchain, a space I like to exist, and into a more traditional banking system? Speaking of DeFi, we're now talking about the leading indicator of the bear market, which is DeFi. And I'm not going to tell you the chart isn't lower, but what we can see is this is largely due to changes in asset prices, not asset quantities. So the amount of digital assets involved in DeFi on Solana continues to be strong. And you can see that over $150 million has been raised just in 2022 for DeFi projects building on Solana. That's an incredibly impressive number considering if any of you have tried to raise capital, the capital market conditions now in venture, it's not what it was in 2021. So this is a very impressive number to see, and it's really great to see that the builders who are still committed to building DeFi on Solana are continuing to do so and have access to capital they need to do that. And you can see that just here at Breakpoint. There's over 20 panels, workshops, presentations, and announcements that are in large part or entirely focused on DeFi. I encourage you to check those out. A number of them are happening on the last day on the main stage, so some really good announcements and stuff coming there. Now moving on to NFTs. No segment on breakout success is quite complete without a conversation around NFTs. Users on Solana love NFTs. There's something about the way they've been built on the network that has had a transformational effect on how people use NFTs. And this is not accidental. These are all of the advantages of working in one global state that's fast, cheap, and composable. It just happens that NFTs are one of the best examples of this. So developers are building new kinds of experiences because NFTs are disruptively cheap on Solana and composable. You can look at something like Raindrops, which allows you to mix and match different items that your NFT could possibly wear. You see these things getting integrated into gaming, and you see NFT governance actually becoming something. And this is that intersection we were talking about how DAOs enable NFTs and NFTs enable DAOs, and this whole world ends up being mixed together into totally new kinds of consumer-focused experiences. And it's important to remember NFTs on Solana are very new. The Metaplex protocol launched in June of 2021, and the first breakout success wasn't really until August. So that's just 14 months ago. Let's go through some of the headline numbers here. So since August of 21, there's been over 21 million NFTs minted on Solana. 7.2 million unique owners of those NFTs. That's not unique wallets that ever minted an NFT, that's current holders of NFTs. That's over $3.6 billion in primary and secondary sales on the network, all in just 14 months. These are remarkable numbers, and even so more considering the bear market we're in right now. And these numbers are matching or exceeding Ethereum numbers on almost all metrics except primary and secondary sales in aggregate. And that's incredibly impressive to see as the network matures and grows. So this is where Solana is today. Where Solana is headed is what we're going to talk about next. There are hard problems that are being solved today on the network, and there are hard problems that haven't yet been solved. And that's what we're here to talk about. We're going to talk about a whole series of them, and there's no better person to have this conversation with than the co-founder of Solana, Anatoly Yakovenko.
Wow, thank you guys for being here. I've had like my first coffee in 3 months. So yeah, very excited to be here and tell you about like all the awesome work that our engineers have done over the last year, and the big problems still left to do.
Let's go ahead and start with mobile.
Yeah, so mobile obviously is a big challenge, and it's a big challenge not for the network, but for the user experience and for developers. The business models for Web3 are not really compatible with how the business models work in the big app stores. When you buy to own a video on Amazon Prime, you don't actually own it. You're renting it from Amazon, maybe forever, or maybe whenever Amazon decides not to have that video anymore. So it's not true digital ownership. And that concept of real digital ownership doesn't really work with the way that app stores make their money. Magic Eden can't charge a 30% fee in an NFT that the user sells in an open market. They can't simply sell the same NFT for 10,000 bucks on their desktop and sell the same NFT for $13,000 in the iOS App Store, nor can they eat that fee themselves. And this is really a problem for mobile developers that are really trying to build amazing experiences for their users. So that's the motivation for Saga. It's blood, sweat, and tears to build a phone. It's a little crazy to try to take on Apple and Google at like what they do a really amazing job at. But we're very lucky that Google does make an amazing open source operating system called Android. So the Saga device, fully Android compatible, all the Google stuff works on it. But it also has all the cool features from the Solana mobile stack. So I don't know if you guys have seen the Saga team. They have dev kits that you can play around with right now.
Go find them and check them out. They're very cool.
Yeah, the dev kits are shipping mid-December. And all this stuff is live. So mobile wallet adapter. It's a very tiny but very cool piece of code. When you use the normal Google Chrome web browser, just a normal standard browser, and you go to a Web3 application, and you click Connect your wallet application, it automatically connects from WebSocket to whatever wallet of your choice on the device. This actually works even outside of SMS. So this is a hook to connect all your wallets, and it's a very slick experience. You no longer have to constantly jump views between the application and the signing experience. And on the SMS devices, obviously, the seed phrases are stored in the seed wallet, and when you sign, you have that like Apple Pay-like experience, just tapping the fingerprint scanner.
And that's all on the secure element inside the phone.
Correct. So the big, myself, I worked at Qualcomm for 14 years, and like when I started Solana and just got into crypto, it was just like every cell in my body was just screaming, why isn't my seed phrase in the secure element on my phone? Every phone should be a hardware wallet, and that's the whole point of the seed phrase. And all that stuff is shipped. It's really, really cool that the actual your BIP39 keyword, you can recover it through a trusted display. It's a display that even the Android cannot see. It's basically handled by the trust zone on the device. So you can read your seed phrase securely. You can recover it, so you can enter it back. It's only decrypted inside the trust zone when you actually sign, so for that short amount of time. And it's as close to a hardware wallet-like experience as you can get. I would still very much recommend you have a very separate ledger for cold storage, but for all your hot wallets, I think this is the most secure device out there. And obviously, the DAP Store. So submissions for folks to submit their applications are going to be open in January. And that's the #1 thing that devs have been asking me. How are we going to deal with Apple's policies? How are we going to deal with mobile policies in general? I mean, every time Apple has an NFT announcement, it's like an ad for Solana mobile stack. So the network. Austin talked a little bit about decentralization and the network itself. But a lot of these faces are new. A lot of these faces have been here for a while. I want to remind everyone what Solana is all about. It's a single giant global state machine. Think of it as a single slab of RAM that's replicated around the world, a single set of memory, key value store, NoSQL database, whatever you want to call it, that's synchronized at the speed of light around the world. This is really kind of the engineering challenge that we set out to solve. We've had a lot of challenges over the last year. I would say this whole last year has been all about reliability for the Solana engineering team. And a lot of that, I think we've solved. And you can see from these graphs, things got really, really bad in June. So block times went up to over a second, which is really slow for Solana. actual throughput drop because of that to below 1,500 TPS. But what that may seem like a lot, but to users, that's translated to confirmation times that we're taking 15, 20 seconds sometimes. And that's not the experience that we want to deliver. And that's a pretty bad Web 2 experience when you're competing with Google, with Facebook, with all these other applications.
Yeah. So after 110, we see these lines starting to converge. What are we seeing there?
It's gut-churning for engineers to see a live system underperform when you know that you have built and fixed a lot of these problems. But you still need to go through audits. You still need to go through testing and get all of these things released. And with 110, we saw both block time strength to sub 500 milliseconds and confirmation and overall throughput go up to well above 2,500. And this is my favorite up and to the right graph in the world. When throughput goes up, it means the user experience is better. It actually means decentralization is more viable, because we did this all without cheating. There was never a time where we shut down validators or asked anybody to stop voting or participate in the decentralization part of the network. The entire network actually doubled in terms of validator count over this period, because we are wrestling the trilemma bear, like bare hands, basically. It's a very hard problem. You're in constant fight with between performance, security, and throughput and decentralization. All of these problems have what Kevin Bowers from Firedancer calls an Amdahl's war. Whenever you improve one, you may actually hurt some of the other ones. But I think we've done an amazing job in solving a bunch of those. Obviously, we still have challenges with outages and bugs like that, and having a second implementation and a second client built by a different team with a fully separate code base, the probability of the same kind of bug existing in both is virtually zero. So I'm very excited to see Firedancer make the kind of progress that they have.
So talking about some of these hard problems that engineers are solving right now, you mentioned Firedancer as one of the core pieces of reliability. What are a few of those other improvements on the network?
So one of the challenges that we faced is dealing with fees and prioritization on the network. Solana is a parallel state machine, meaning it can do more than one thing at a time. EVM-based blockchains, and I think most of the other blockchains that have launched that they're not even EVM-based, cannot do more than one thing at a time. There's a single fee market, a single way to prioritize events. And that is actually creates very, very bad experiences for users. When you have an airdrop and an Oracle update and a liquidation all happening at the same time, all of those things start bidding up the price for block inclusion and effectively outbid each other and cause these massive fee spikes. This is a classic database hotspot problem. There's no magic zero-knowledge way to solve it. There's no layer 2 solution. You actually have to separate those states and put them in separate buckets. And the three technologies that enable Solana to do that are Quick, that limits very spammy bot from sending 100 gigabits worth of spam to the network. QoS, that prevents unstaked nodes or low-stake nodes from spamming out everyone else. And localized fee markets. So this is the localized fee markets. Sounds like a simple problem. We basically try to look at all the state that's available on the chain and price it accordingly, and then take the top auctions. But it's also an NP complete problem, the knapsack problem, and we have to do it in real time. So it is definitely one of the really fun engineering challenges. But folks from Judo and from Mango Markets have actually contributed a ton of code and analysis to improve that, to improve the heuristics to make that better.
So how does something like Judo, which is a MEV-optimized client, fit into that idea of local fee markets?
So they've built a separate mempool and basically a redundant way for DeFi applications to land their transactions into Solana. And not only do they land single transactions, they allow searchers to schedule multiple events that all land in a bundle, all at the same time. And that's very important for DeFi, and for a lot of DeFi applications depend on having very complex interactions between lending protocols and markets.
Right. So now on to programmability. Token 22, I know a number of devs are pretty excited about that. What's in that, and why should devs be looking forward to it?
It's a new token standard. It extends the token program with in an ABI-compatible way. So if you've already used the old SPL token, you can basically enable this with just adding another program ID. But it adds a whole bunch of other features that enable new applications, from collecting royalties on transfers or on ownership, and even things like confidential payments, where the amounts, the values that are actually transmitted between users are encrypted. So the best example of that would be the Constitution DAO. When Ken from Citadel knew exactly how much the other side was bidding, he just bid $1 more than that to win the Constitution. But if that amount was encrypted, they could have actually had some game theoretical auction that maybe the Constitution DAO would have won.
And looking at changes to programmability through the addition of new languages, there's a bunch of work being done in a few different ways by some teams.
I've always said that Solana is like Linux. It should be as programmable as Linux. That means using modern tools like compilers to support very large set of developer languages. So there's a very mature Solidity compiler already available, Solang. So I hope devs go check it out. I suspect the next hackathon is going to have Solidity submissions. And you can actually start using Anchor IDL to talk between Rust programs and Solidity-based ones. There's a Move project started already, again, compiling Move through LLVM into Solana bytecode format. And what was really cool is just a dev on their own built Python support. So a Python transpiler that takes Python using the amazing Python transpiler tooling and compiles that to Rust. And the amount of code that you actually see a Python's like implementation of a smart contract, I think is like a factor of 5 lower. So it's really, really cool to see like folks create this tooling to make developers just go from 0 to 1 much, much faster.
And Python's also a quite common language.
Yeah, it is probably one of the most used languages across many different industries. So most developers that are not just front-end developers or back-end developers, I think just about everyone has written some Python.
Yeah, and speaking of things that make it easier to develop, I mean, Anchor.
Anchor, I think we went from chewing glass last year to surfing glass. And I think a lot of that is thanks to that gentleman over there, Armani, and the work that they've put into Anchor. So buttons.
All right. So let's talk about a few of the other categories of problems that developers are actually working on solving now on the network. So let's start with performance and some of the updates there.
So a lot of the performance improvements that we saw with 1.10 release were actually way deep under the hood. These were turbo-in optimizations, which is how Solana propagates blocks. We have that very stringent goal of making sure that information gets transmitted around the world at the same time. And if folks from Jump and a bunch of RPC providers have measured this to where you can see that blocks propagate from around the world to every node in the network, doesn't matter if they're a stake node or an RPC node, within 15 milliseconds. And I think this is like probably the coolest piece of technology that we built that is probably nobody knows about. And a lot of the improvements and a lot of the work that we do goes into that deep networking analysis.
And then in terms of runtime optimizations, there's a bunch of work being done there too.
Yeah, when we launched with a very safe implementation of C-level. It was still probably, I think, the fastest runtime in crypto. But me as an embedded systems engineer, we committed a lot of memory crimes. There was a lot of memory copying between instructions in every call to external programs. And our amazing runtime team has been doing a lot of optimizations to remove those piece by piece. So all those replay optimizations, making the network much faster at processing transactions, just one by one, have dramatically improved. And the two other really hard problems is the transaction scheduler, which is that real-time knapsack problem, and then playing the transactions back in parallel as fast as possible. Both of those have had a lot of work. These are, like those kinds of engineering problems that you can spend a lifetime on. These are NP-complete problems that are hard. So for engineers, these are the fun and like super deep problems that you can really geek out on. And the solutions are getting better and better, and heuristics are getting much closer to the best possible you can have.
And so moving on to security, to start, the number of validators on Solana has almost doubled since last year at Breakpoint. More validators mean more security, but how do these things filter into the long-term relationships on the network?
So you gotta kind of like ask yourself, how many validators do we need? Doesn't matter if we have 100 or if we have 2,000. I think if you really imagine these networks taking over the majority of finance, like real finance, trillions of dollars being moved between banks, between Forex, between payments, you need to have a lot of security. Like these networks need to provide guarantees that are much, much stronger than what exists today. And I don't know if that's 2,000 validators or 20,000 or 200,000. So this is the challenge with the trilemma. How do we scale the set to the point that at a gut level, when you're like the chief security officer at Bank of America, you're like, well, I can trust this thing because there's so many nodes that the probability of something going wrong is basically 0. So this is going to be a challenge, I think, for everybody in crypto, including us. But as you've seen, like folks like FireDancer demonstrate, there's a lot of hardware, even like commodity hardware can scale to very, very large number of throughput. And that throughput literally means decentralization for Solana. The more transactions we can do per second, the more validator votes we can handle, the bigger the network and the bigger the amount of folks that are constantly watching the state and can alert of anything going wrong. The bigger that set gets, the more secure it gets.
So talking about automated audits, that is another security improvement that helps reduce the attack vector available, right?
Yeah, so both Sec3 and AuditorSec have done a lot of work in automating basically a lot of the basic mistakes that people do with smart contract development. It's never going to be perfect, but the tools consistently get better, and developers can quickly identify when they made like a common mistake. And these are very important steps to actually make sure that smart contracts don't have those common developer bugs. But you're still never going to be able to fully confirm that this code is safe. This is one of the hardest problems in computer science. At the layer 1, we actually have an easier problem. We can have a separate team build a whole separate implementation. So the probability of the same human error is virtually 0. But there's only one smart contract instance. There's only one of those, and you cannot really have a duplicate one. And that's a very scary thing when you're talking about actually handling real-world finances through these systems. So as much automation as we can build, the more robust that these systems can get.
So we've been talking about a whole bunch of hard problems that engineers are solving on the network today. Let's talk about some of the stuff in the future.
Yeah, the difficult bombs on Solana. Luckily, we don't have a difficulty bomb. We're already POS, so I think it's downhill from here. But there's still a lot of really hard problems left.
So these are some of the really hard problems in programmability that are still to be solved. Let's talk a bit about formal verification.
Speaking of security, when we talk about this idea that there is no second implementation for your smart contract, one way to get close to that is to actually have a formally verifiable spec, which then can be automatically verified. And you can think of that spec as that second implementation. And there's amazing tools that have been built for Rust, Connie and Prousty, that enable this. And the whole Viper formal verification framework can be used for arbitrary languages. And my hope is that next year at Breakpoint, I'll be talking about the smart contracts that are open source, have formally verifiable specs, that auditors can look at the spec and tell you where you're missing an assumption or an assumption is not possible to prove, and that's the area code that you need to exhaust in your testing. But we're really not even close there. And I think this is one of those challenges that can definitely be solved in the next year because the tooling is there already.
Okay. So formal verification is an improvement to one piece of code in a spec in a smart contract. What about type-rich bytecode?
This was something that was basically science fiction when I was an undergrad 20 years ago. And this is this idea that you have machine code that's executed by computers that has strong types embedded into it. We are lucky to stand on the shoulders of giants here. The Linux folks that are building Berkeley Packet Filter actually added the Berkeley Packet Filter type format, BTF for BPF. And that is a very cool technology because that actually creates types for all the generated code for the actual machine code that's the BPF module. What's cool about this is that it really removes a lot of the boilerplate between programs. So when one program has to call another one on Solana, right now it has to go through this plumbing called the cross-program function invocation. And that plumbing requires the developer to construct the accounts and to pack data and unpack it on the other side. Well, why can't we just call functions directly between programs? With a type-safe bytecode, you can actually have guarantees about memory and safety between those cross-program calls. And it's as if you're calling a function within the same source code as a developer. This is really like the difference between, in my mind, full composability in a world computer and like passing messages between like different services. And I want that full composability. I think once this is enabled, the amount of code and cross calls between programs is just going to explode. And the kind of things that developers will build, I think, will blow everyone's mind. So very excited about the possibility of taking this work that the Linux folks have done and turning it on Solana.
Yes. So let's talk a little bit about network state and dynamic pricing for storage.
So everyone, I think, in every crypto layer 1 is worried about state. This is like one of those really tough, gnarly challenges. What happens when you have like 5 billion accounts or 10 billion accounts? We've actually done a lot of optimizations over the last year to just scale it with hardware. We've done tests where the network is, you can load it up with 8 billion accounts. It takes about 4 terabytes, which is still commodity hardware. And it runs fine. It boots up from snapshots. All the work for differential snapshots were actually done to enable this. But that still doesn't mean that we know how to price that storage. We don't know what the value of the next account should be to the validators and how to make sure that that storage is used effectively and the economics of that are worked out. There's a bunch of research that's been done on this, and I think it's time to experiment and see which implementations make sense for the network to make sure that the validators can always keep up with the demands of the users.
So those are all really difficult problems for programmability. Let's talk about some of them at the network level.
So we have a bunch of validators. How do you know that the network is actually secure? There's been a ton of research in layer 1 development for these things called light clients. And what light clients do is they allow a user that's not running a full node to sample a small set of validators out of a very large pool of full nodes and check, do all of them agree that the majority is not lying to them, that the majority didn't create 2 forks, or the majority didn't validate an invalid block. And these protocols are called light client protocols, and they give the light client honest minority assumptions, meaning that if you have 2,000 validators, maybe you only need 50 of them to remain honest for you to have the same guarantees as a full node. And when you're talking about scaling crypto to 10 billion users, there's no way that you're going to have 10 billion full nodes. That's just not possible. But you can have light clients. You can have a very large validator set. Maybe it's 2,000. My gut says it's probably going to have to be closer to 20,000, if not 200,000. And you have the sampling protocols that can provide very robust guarantees for the users that the network is still functioning correctly, that no one somehow hacked into a majority of the voting keys by stake weight and caused it to confirm an invalid block. So we need these protocols to give robust security guarantees when we scale to very large user bases.
So how's a diet client different from a light client?
Because Solana is a big fat protocol, the proofs are much fatter than something on a very thin protocol layer. So that's why we call them diet clients.
All right, let's talk about bankless leaders and block production.
So this was something that if you've been an engineer in Discord and following our engineering work in Discord, I've probably brought this up every 2 months. Let's separate block production, the actual job of making blocks, from the validator itself. What this allows to do is it allows the actual block producers to be a bit stateless. They don't need the most synchronized state. they can spend all of their resources on this very gnarly real-time knapsack problem of creating blocks. And these block producers can actually be hosted on separate machines, totally separated from the validators actually doing the verification of the code. And that's a huge reliability improvement and a pretty significant improvement for latency. Because now when a client sends a transaction to this block producer, the block producer isn't executing anything. It's just packing blocks. And it can notify the client that their transaction is valid enough and has been transmitted. And the client can then actually know and observe that block being propagated much, much faster.
And this all rolls right into Apex as well.
So asynchronous block production, stateless block production. The other side of that is, how do we make this network resilient against very spiky requests for demand? When you actually look at Web 2 traffic, it's not uniform. You never see the same constant number of users every minute, every hour. You see very huge spikes for demand for anything, for storage, for compute, for connections, for payments. And what you really want to do is you want to average out those spikes over a longer period of time so you can use all those resources to process them. And the way that we can accomplish that is we can separate the work of executing all the actual work of playing the blocks back from picking forks. The only thing the validators need to do is they need to observe that the data got propagated, and they can pick the heaviest fork based on that just assumptions about propagation. Because once you pick a fork, you know the execution and you know the result. And if we can accomplish this, that means that you can have actual program execution run a full epoch behind fork choice. That gives you 2 days worth of transactions to execute at once. That means that you can load them up on GPUs. You can take your time to create very big batches of work and execute them all at once. And in some cases, it might even be possible to use zero-knowledge provers that take a very, very long time to prove something. So this is one of those big challenges. It's not hard conceptually, but because this code is so intertwined with how consensus works, it's a very, very gnarly engineering problem.
So all of these hard problems yet to be solved, what do these all lead up to?
Well, the soul of what Solana is all about is trying to create a historical record of the world that's as close to reflecting the real-time events as possible. We really want to make this idea, the ledger, it's called the proof of history ledger for a reason, that the events as they occur in the world reflect, in that ledger, reflect how they actually happen in real life. That's very important for finance. If you're the first to recognize an economic opportunity, you should be the one to get credit for it, to be able to take it. So we want to reduce the latencies between users and the network. And one way to do it, if you're imagine the current world, there's only one leader, one of those red dots. Let's say it's the red dot in America. The Monkey King has to send his transactions all the way across the Atlantic Ocean to the United States. And the Solana Summer Monkey can only send them terrestrially, right? Just across the United States.
And that distance is a meaningful amount of time.
That is tens of milliseconds. I think in that case, might be close to 50 or 60. That's a very long amount of time. So even if the Monkey King was the first to recognize an economic opportunity, or the first to see that event, or really just a Web 2 user that wants a faster experience, that's a very long time to travel. Now, if you have multiple concurrent block producers, you can actually split them up and run them in different parts of the world so that latency drops. The Monkey King actually has a very fast path to Ireland, and that cuts the latency down by 50, by 60 milliseconds. Google famously had a 200 millisecond requirement for all search results in the 90s. 10 years later, they wanted 50 milliseconds. That meant that they had to have local servers responding to local requests near where the user is. And this is where we need to get to if we want to be competitive with Web 2 services. And there's nothing stopping us. It's just a bunch of work.
So, just a bunch of work. So, multiple concurrent block productions. That sounds a little bit like sharding.
It sounds like sharding, but it's not. We still have a single state machine, a single unified worldview of what the state is. We just have multiple ways to encode that history. And because of the way that Solana Ledger is constructed using a verifiable delay function, when you actually examine this history, you can basically zip it together. And the transaction that appears earlier in that history, we have a proof that it actually occurred earlier in real life, and it should be executed first. And that's the really, really cool thing about how Solana works, that we're really building something that's trying to get to consensus at the speed of light. We want to synchronize the world at the speed of light, as close as physics allow. It's a really, really fun, hard engineering problem. I wouldn't be working on Solana if it wasn't for this problem. It's something that I think about every day, and it's awesome to work on it.
Yeah, one of the things.
Thank you.
So one of the things I really love about this is today there's an assumption that decentralized blockchain systems have to be slower than centralized systems. But this shows that isn't necessarily the case.
Yeah, I don't think so. This is my belief, is we can make these systems as fast as the best of centralized systems. It just takes a bunch of work and some organized sand. So thank you, guys. Thank you for coming. It's awesome to see all these faces here. I'm like honestly kind of flabbergasted. There's like almost twice as many people here this year than the year before, and I think probably 20x more developers. So check out all the events. Check out the Fire Dancer demo, game day, all the games being built on Solana. Yeah, thank you for being here.
Nice.